Okay, so we've talked about this a little bit the other day. And then we talked about addition and subtraction of fractions, but sometimes, especially with adding, you get an improper fraction. So we need to be able to convert that to a mixed number. Let's go ahead and look at how we would do this. So everything that I do, you are going to do in your journals, right? Okay, monkey see?
Monkey do.
All right, so let's start with a pretty easy one. Let's do 5/3. Let me change pens. Okay, 5/3. Now, if I have the fraction 5/3, it's pretty easy to see using a model what 5/3 looks like. Because there's 3 pieces, 4 pieces, 5 pieces right there. So using a model, it's pretty easy to see that I have 1 whole and 2/3 left over, right? Mm-hmm. But we need to be able to do this when we don't have a model to use, be able to figure out what would be my mixed number if I just have numbers, okay? So 5/3, I can rewrite that so that I have 1 whole plus what's left over. I can decompose that fraction into parts. So how many pieces does it take to make 1 whole? 3. And we know that because of the denominator, right? So I know that if I take 3 pieces from my numerator, okay, I take that away, that gives me 1 whole, then I have 2 pieces left over, right? So that means I have 3/3 and I have 2/3. So this 3/3 gives me 1 and I have 2/3 left over. So this equals 1 and 2/3. Okay? Let's look at another one. Let's say we have 8/5. 8/5. Let's do that fraction, 8/5. Okay, now again, I could use a model. Let's do a simple strip model. And I can divide it. How many pieces am I dividing my model into?
5.
5. So I have 2 different whole strips because I know I'm going to need more than 1. And I have to divide it into 5 equal pieces, the best that you can. 5 equal pieces. Now the numerator tells me how many pieces I have or that are shaded or whatever. So I need to shade 8 of them. So there's 5, 6, 7, 8. So now I have 8/5. And with my model, it is easy to see that I have 1 whole and 3/5 shaded, right? So I have 1 and 3/5. So let's see what that looks like if we're decomposing our fraction, right? So from my numerator, I need to take away 5 pieces to make my 1 whole, right? So that means I've got to have 5/5. But how many pieces are left over? I take that 5 away from the 8. That gives me how many left over, Sean? 3. So 3/5 left over. So I know I have 1, because this is 1, and 3/5. Are we kind of getting the hang of that? Okay, let's try one a little bigger with some bigger numbers. Okay? What if I have, let's see, 17/5?
That's really mixed.
17/5. Now, I need to figure out how many wholes can I get out of that, right? And then how much is left over. It takes 5 pieces to make 1 whole, right? Okay, so I know I can do 5/5. So if I take 5 away from that 17, I still have 12 pieces left over. So can I do another whole number? Yeah, so I can do another 5/5. I take that away from the 12 I had. That leaves me with 7. Can I do another one? Yes, so I can do another 5 over 5. I take that from the 7, and I get 2. Can I do another whole number?
No.
No, so that's what I've got left over. So 2/5 is what I have left over. Now notice my denominator is not changing, right? It still takes 5 pieces to make one whole. My denominator through this entire process does not change. Okay, so now I've got to see how many whole numbers do I have. There's 1, 2, 3. So I have 3, and then I have 2/5 left over. So 3 and 2/5. Gucci? Okay, let's try one on our own. So I would like for you to try, go ahead and do this in your journals, 12 over 3. 12 thirds. You know what, I'm going to change that, I lied. Make it 13 thirds. 13 thirds. All right, try that now. When you got it, give me a thumbs up. Most of us are done. What did we end up with? 4 and 1/3. Now, I saw you guys using a couple of different strategies. I saw some of you drawing models. I saw some of you doing the addition. I even saw a couple people that did it in their head. Okay, which is fine if you're able to do that. Okay, but one of the things that we do is we're taking 3 pieces away until we can't take 3 away anymore. That's repeated subtraction.
Awesome.
Now, when we have repeated addition, what's another way that we can come up with the answer when we do repeated addition?
Maybe we could get the answer and check it by adding everything back.
Jillian? Multiplication, right? Remember when we were first learning about multiplication, we learned that it's the same thing as adding that number of times. So if I do 5 plus 5 plus 5 plus 5, that's the same as 5 times 4, right? Well, repeated subtraction then is kind of the same as what? Division. So what if I were to take this 13 and divide it by 3? If I take that 13 and divide it by 3, I'm doing repeated subtraction only faster. How many times does 3 go into 13? 4. So 4 times 3 is 12, and I get a remainder of 1. So this is my whole number, and this is my leftover pieces, and my denominator never changes. My denominator is my divisor. So by doing division, I can convert to a mixed number faster than doing repeated subtraction. Does that make sense? Okay, so here I'm going to tell you something. I want you to think about it. This symbol right here, that little slash in my fraction, that is a division symbol. It is another way to say divided by. Got it? Okay. We see this as fractions, but that symbol means divided by. So if I have a larger number, let's say I have 235 over 12. I have 235 twelfths. Do I want to sit there and do repeated subtraction until I get the number? No. But what did I say this symbol means right here? Divided by. Now, top dog always goes in the doghouse. All right? So 235 divided by 12. How many times does 12 go into 23? One time. I get 12 with the remainder of 11. How many times does 12 go into 115? 9. 9 times. What's 9 times 12? 108. And how much am I going to have left over? 7 pieces left over. Now, what did I say? This number is what? That is my whole number. And this number is the pieces I have left over, right? So that is my fraction, which is going to be 7/12. Remember, my denominator and my divisor are the same thing. Doesn't change.
Okay.
Got it? Awesome.